This next example is an example of going backwards. Given the mean and the standard deviation, we are trying to find what reading score would be the cutoff for the top 15% of applicants who are applying for a letter sorting job, and they've been given a speed reading test. So in honor of Carrie Underwood, we're going to undo it. First step is very similar to what we have been doing in the past. We identify the normal curve with a mean of 80 and a standard deviation of 8. We have our z-score already written in for us down here, and now I'm going to write the x-score, the raw score scale, and we know that this is 80, 88, 96, and 104. Going the other way, I would have a score of 72, 64, and followed by 58. Okay, the next thing we want to do is use our knowledge that we have already. This, in fact, would be a 56. Use the knowledge that we have already to determine where we think 15% of the top area under this curve is. And that's one reason why we have spent so much time on the empirical rule. So this is hopefully a quick job and an easy job for us. We know that if we start at 1 standard deviation, then over on this side of the curve is 16%. I want the top 15%, so I just want to be just inside of 1 standard deviation. So in fact, I am looking for this area, and I know that that area is equal to 1, 5, and I'm going to put 2 zeros over it because we in fact will be looking inside the table and then to the outside of the table to find the z-score. That's one of the ways that this is a problem in reverse. From here, I can guess that my z-score is going to be 1 point something because I'm just over the 1 mark, and I can guess that my raw score is going to be in the 80s or low 90s. So I'm just going to put that in as a guess to remind myself. 80s or low 90s, high 80s or low 90s. The next step is to write my probability equation. I'm looking for scores that are higher than 80 or 90 something, which is equal to a z-score being greater than 1 point something, which I know is approximately 15%, the top 15% of all applicants. Okay, I'm now going to need to go to my table and look up 15%. So this is the front of the table. I need the back of the table to find 0.1500, as close as I can get. Over or under, it doesn't quite matter. And I'm looking right here. This is 15 too high, 15 thousandths too high. This is 8 thousandths too low. This is lower, so I think the closest one is at that spot. So now I'm going to take this number and I'm going to look for my z-score. I have negative 1.0, and at the top that's 0.04. So I'm going to use negative 1.04 as my z-score. Come back to the curve and we put our negative 1.04, And suddenly we see that we have a mistake. I thought the z-score was going to be in the +1 area. And so what that means is when I use the table, it gives me the area to the left of my cutoff line, and that area is 0.8500. So in fact, I looked up the wrong area. And so this again is helping us not to make a careless mistake. So I'm going to have to not use -1.04, and now in fact I will go to the back of the table and look up 0.8500. And 0.8500 is going to be somewhere in this range. This is down a little further. I have 8 too high, and this is 15 too low, so I'm going to go with this one. And that's the score that I can get that's closest to 85%. I look up and down, or over and up, to get the z-score, and it is in fact a positive 1.04, which is not a coincidence. It is the positive of the negative z-score that we found earlier. If you knew that already, then good for you. You can, if you're comfortable with that, then you can always look up the lower number and just remember to check on whether it should be a positive or a negative. So I know my z-score is 1.04. And now I have one more time I have to undo this to find my raw score. And again, I'm hoping for my raw score to be in the high 80s or low 90s. So we have this equation. Z-score equals the score minus the mean divided by the standard deviation. I know 3 of these numbers. I am looking for the raw score. So I can plug these numbers in. 1.04 equals x minus the mean, which was 80, divided by the standard deviation, which is 8. And now if I undo that equation by taking 1.04 times 80, times 8, and then adding the score of 80 on, I find out my score that I was looking for is in fact 88.32. So x equals 88.32, and that matches my guess. So I'm feeling pretty confident about that. Put it into my sentence in the right spot. This is actually the answer to the problem. And that answer to the problem, therefore, is 88.32 points. So my guess is they will probably take scores of 88 points or 89 points, depending upon how many places or how many people they want to spend time interviewing. And that's how you do a problem where you're given the area and you're trying to look up the score.